All right then. Well, it's really great to be invited on this presentation with Locagen. They really align quite well with what we're trying to achieve at Advantage Utilities for our clients, which is to navigate the energy crisis through forms other than simply having the most competitive energy contract, but looking at other methods of on-site generation and on-site efficiency. Therefore, that brings me on to today, which is how can UK businesses control their energy costs? So we're going to break it down into the current energy market and how that price volatility has been, and then what that kind of looks like going forwards. And although this section looks very long, it's actually quite short, and we'll talk about the efficiency and infrastructural enhancements going forward. So let's start with the energy market. So what's really important to know is there's two energy markets at play here, which is the gas and the electricity market. And what we've seen over the past, well, 12 months, now approaching a bit longer than that really, is just incredible increases in price. And this has been termed the energy crisis. And the headline reasons for why we've observed this is we've just seen a decrease in supply to the international markets. And then in the United Kingdom and other places around the world, we've had reduced natural gas reserves following the COVID-19 consumption and then decreased supply. And then what a market doesn't like is uncertainty in supply. And what's happened since the Russian invasion of Ukraine is just hyper uncertainty about future supplies, especially to mainland Europe. So this is what it's been looking like since November 2020. We had quite a stable period of price markets over the since then. And then what happened around Q4 of 2021 is we observed a 10-year high in prices. So this is gas on the right axis and electricity on the left axis. And what we're showing here is seasonal variations, because you purchase your energy most commonly in seasons, it being the summer season and the winter season. And yeah, what we saw in Q4 was what we first termed the energy crisis. And this was the previous 10-year high, and everyone thought, oh no, it can't possibly get worse than this. How dramatically wrong we were. And what really happened around Christmas time, I remember looking at this and thinking, why have the markets gone completely mental over Christmas? We're supposed to be on holiday and not thinking about these kind of things. But then we reached another 10-year high. And we thought, wow, okay, it can't really get worse than this. And then, well, when you had the Russian invasion of Ukraine, not only were we worried about storage solutions, but then we also had hyper uncertainty in the market. And then what's happened since that initial invasion is we've had these consistently high prices. And then when you start influencing other forms of supply, such as the Nord Stream supply chain, which goes through from mainland Russia into Germany predominantly, and then the falling offline of Nord Stream 2 altogether, we've just had such hyper uncertainty. What we've noticed in the past, well, the last few weeks really, is now we're having a little bit more confidence introduced back to the market, and that's predominantly from the price cap. The government were introducing the price cap, which is actually not a price cap, it is a price subsidy. And what we've also seen is increased liquefied natural gas, which is in those increasing supplies have now meant we've got a little bit more supply certainty and then a little bit more price certainty as well from external factors. So what really matters in the energy market is, especially in the United Kingdom, is actually the price of gas. Now, the reason we care so much about the price of gas is because gas is responsible for at least 60% of all electricity generated. Therefore, gas provides the base load of our electricity generation in the United Kingdom, and as a result, the electricity prices will follow the gas prices. Now, going forward, this may not necessarily be the case because gas is actually subject to order of merit purchasing. And what's really good is that renewable sources such as wind and solar are significantly cheaper than gas and oil. The same goes for nuclear. We've kind of phased out coal now. It still exists in some European countries and some Asian countries, but not in the United Kingdom as much. So as these other renewable and nuclear sources become more important, we'll start to see the decoupling of gas prices and electricity prices. But clearly, based on the market, we are absolutely not there, and therefore very vulnerable to gas price volatility. So then this brings us on to what's the long-term outlook and what's the solution? Well, the long-term outlook is you have to look at what actually goes into the price of gas and electricity. So the actual cost to customers is made up of wholesale market costs, addition to the non-energy costs. So the wholesale market costs are quite simply what is generator X able to sell it to consumer Y for. But then we have the additional non-energy costs. And these could be, for example, your renewable obligations. That's a tax imposed by the government in order to fund renewable investment strategies. So to be quite honest with you, the long-term outlook is very much a £1 trillion question because it is a £1 trillion industry. So I've estimated that the long-term outlook will be somewhere between 20 pence per kilowatt hour to 32 pence per kilowatt hour for electricity, and gas of somewhere of 5 to 9. And for electricity, this is based on us going back to still uncertain pricing terms. We'll probably never see COVID prices again, but in theory, once we've got our supply with more certainty, that should bring prices down. That will be related to the de-escalation of Ukraine, having additional gas storage facilities, which is the North Sea rough gas storage facility. And then as we increase generation from different renewable sources, that will decouple it from the gas prices. And as shown earlier, renewable input is significantly cheaper than gas input, which overall should decrease the price of somewhere, hopefully, 10 to 20 pence per kilowatt in the wholesale market. Now, for the non-energy costs, simply put, they are dictated every 12 months by the government. And what we know is that they've historically increased over the past 10 years plus. Therefore, probably looking at those increasing at 10 to 12 pence per kilowatt hour on average, which is how we've come to 20p being the lowball estimate and 32p being the optimistic highball estimate. But what is the actual long-term future? Because historically, these prices have been closer to 2 pence for gas and 15 pence for electricity. What can we do as businesses to get back to that situation? And the answer is we just need to have an integrated energy solution on a firm-by-firm basis. So previously, we would always try and manage the costs by just having the best gas and electric contracts we could obtain. Now what we need to do is have a more sophisticated approach, which means that we need to integrate new technologies that will decrease the amount that we purchase from the wholesale market through either enhanced efficiency of our infrastructure or through enhanced on-site generation through things such as solar PV or wind. And what's really good is that the cheapest method of gas and electricity is actually through your on-site generation, which is really good because now, in terms of market forces, the best cost-saving technologies center around CO2 reduction, which means that you can have an integrated sustainability and economic outlook. So this is quite simply highlighted most recently by the Prime Minister when she addressed Parliament for her budget. It's a really powerful quote, which is echoed all through Parliament, which is, in the meantime, companies with the wherewithal need to be looking for ways they can improve their energy efficiency and increase their direct energy generation. So when we're talking about on-site efficiency, we're talking about different factors such as LED technology is the most obvious one, but then we'd be talking about smart building solutions, more efficient boilers, voltage optimization devices, and then enhancing our heating, ventilation, and air source pump and our heating solution. And then I'm happily going to pass on to David, who will talk us through how we can enhance it through on-site generation through various different technologies. Thank you so much for listening to me today, and I'll pass you over to the very capable hands of David.
Thank you very much. Right. If I just bring my screen James, did that work?
Yeah, I can see it.
Marvelous. Okay. So thank you very much. So as James says, Locogen, we focus on the renewable energy generation side of this equation, and our background is very much in terms of supporting organizations, both developers and industrial organizations, in terms of understanding how those on-site generation and off-site generation in some cases can support their sort of energy progression and they meet their net zero carbon strategies. So one of the sort of main things we have to sort of get around initially in terms of on-site generation is the change in how we are viewing the investments that are made in terms of renewable energy projects. For many, many, many years, we have had a system where the government has incentivized the installation of renewable energy technologies, both heat and power systems, through kilowatt hour pricing. They would provide the feed-in tariff or the renewable heat incentive, or prior to that, the ROC, as systems where you would be paid for every kilowatt hour or megawatt hour you've generated, and the government subsidized it. And it was some of the things that were on James's graph before, as those sort of a non-unit price, non-commodity pricing. All of those schemes have now gone. And they were great if you were able to get in and get them at the time, and those tariffs will continue to run. But they are not coming back. There is no discussion or possibility about the government bringing back any form of this kind of incentive scheme as it stood previously. It's important because some of those generation options are still around. We'll touch a little bit on how some of these go, but about where they can fit back in. But there are still opportunities to either enhance existing generation schemes or to buy systems from other sites to include in your buildings, in your businesses. So it's worth being aware that that is how things were done, and some of those projects still have some life and some financial viability. Any project going forward, any new scheme that's going in, is not going to be funded in these mechanisms. We are looking at them as standalone investments, and we're looking at them in terms of offsetting the now increasingly high cost of energy that we're using on site. There are some grants around, and they are predominantly focused around new and innovative technologies. So for organizations which see an opportunity to invest in more advanced technologies, things that are more experimental, then there are some incentives available to support businesses and organizations that want to go down that route. Touch a little about those on the end, towards the end. But you have to be aware that the reason they're putting money into it is because they are more experimental. So there are risks associated with any of those types of projects, and they are all time-bound, and they are technology specific. So they will open a pot of money, they will say, this is for doing this particular thing, maybe hydrogen in a particular business, or a long-term energy storage market for a particular application, and they will invite applications, and when they've got all those in, they will stop, and they will close, and that was it. That opportunity may never come around again. So it's something that has to be sort of tracked and kept on top of. Really big schemes, you'll see things like contracts for difference. But the kind of projects we're talking about here just are not likely to be at a scale where any of those types of mechanisms are going to be suitable. There are sort of alternative investment strategies which have come about, where if you are interested in the types of technologies that we have here, but the capex is not something that you can invest in, there are organizations that will come along and provide that as a service. We're seeing this coming through increasingly over the last few years, where people will offer you a sort of fixed rate deal to deliver that energy to you. It depends on your business's outlook in terms of what you can accept, and what security you can give to being able to give that consistency of energy purchase. So for on-site generation for renewable electricity, the key things we're looking at are wind and solar. Solar PV has become the sort of go-to for all on-site generation options, because it is the easiest thing to install, and it is the least regrets of all of the generation technologies. Wind is more complex because you need the right wind resource, and it has impacts to do with visual and noise. There are some situations where we see hydro installations come in, but as a whole, the number of hydroelectric installations that are going in has dropped dramatically since the feed-in tariff stopped, because almost all of those hydro installations were grid-connected systems that are away in the Highlands of Scotland or miles and miles away, and very, very hard to direct wire into a building. So with all of these systems, we're initially looking at things that can be wired in behind the meter, so directly into the electricity consumption of your buildings to offset the demand at the point of use, because that's where it adds the most value. So, as you said, PV is the sort of primary go-to for this, because most buildings have roofs. The generation varies a little as it goes up and down the country, but we can predict to a reasonable degree what that demand is, what the generation is going to be, and how it'll vary seasonally, much more in summer, much less in winter. So it can be a really good option for a lot of buildings. It's very key to understand how that generation profile matches with the consumption of those buildings. We've seen looked at projects where it will be a dairy, for example, and actually all of their electricity demand is first thing in the morning, last thing at night. And actually that solar PV doesn't fit particularly well, because the generation is right in the middle of the day, and their load peaks are sort of in the sort of shoulders of the day. So the overlap is actually quite small. So there are definitely systems which we've seen where it doesn't fit particularly well. And if you've got high nighttime use, again, for obvious reasons, that's not going to be very effective. So on its own, PV may not suit all sites, but broadly, it tends to be the sort of go-to initially for most organizations. It's the limiting factor for PV is usually the amount of roof space that you have. We tend to see a lot these days where the roof space is nowhere near sufficient to meet the vast proportion of the on-site consumption that's required. But it varies very much on different business types. There are logistical considerations that need to be considered. In England, permitted developments up to a megawatt on roofs. In Scotland, it's only 50 kilowatts. You have to think about business rates, which is something that quite often isn't included in the models that people will put forward to you when you're thinking about the investment. Does need to be considered. Any financial model or projection that somebody gives you doesn't include business rates is criminal. In the metaphorical, not legal sense. So you need to be aware of the different kind of issues associated. In terms of capex, the capex for PV was driven down over the last few years, with availability and supply chain issues compounded by the massive increase in demand for PV. Those prices have started to creep back up again. Our biggest issue at the minute is finding installers to come and fit PV systems, because there is a dearth of opportunities for them at this point in time. So that's procurement-wise, there's lots to be considered. CapEx-wise, we're still looking around sort of £700-800 a kilowatt peak installed for roof-mounted systems. Is a sort of working figure. It does vary. Operational cost of PV is low. There's very little to do as long as you can keep the systems clean. One of the disadvantages that we see with that is that because of the low OPEX costs, we do see a number of businesses where they've had PV installed and nobody's actually keeping an eye on it, and frequently walk into sites at the minute and find that the inverters have tripped out and not been reset. So it does require a little bit more sort of to get the benefits out of it, to ensure that somebody is keeping an eye on it. But it's a very low interaction, low maintenance system. With current energy prices, if you can get a reasonable amount of that energy that's generated to offset your on-site demand, we're seeing payback periods easily 4 years and below. So it is a very viable investment at this point in time. But you need, and that system will last, well, standard we say 25 years, but people are looking at 30 or more. So it's more about each business's understanding about how they're investing, what they're doing in terms of the building, what they're going to be using those buildings for that period of time, which starts to become more key. But it makes it a much more viable sort of investment horizon than when we were looking before. It could be 10 years plus. In terms of wind has the advantage that it's got a much smaller physical footprint. It has a higher capacity factor. It tends to generate more energy per megawatt of system that you install, but it's more site specific. You need that wind resource. It's not windy, it's not going to do much for you. And if you are in a sheltered environment, surrounded by trees, surrounded by other buildings, surrounded by hills, again, your ability to use it is going to be limited. So resource is key. The main limiting factor for wind is the permitting, planning. In Scotland, we have a slightly easier time of it than the projects in England, but that said, we have seen a number of industrial wind single turbine projects go through in England recently because they have been able to demonstrate that it is integral to the business opportunity, that business viability. It's a good local employer. They need that low-cost energy to keep the business going, and that has helped push that through the planning process. So although it is more challenging in England, these are the kind of opportunities where wind is very, very likely, more likely to be permitted. It's then understanding the constraints. We need to be careful about where wind is sited and relevant to not just the resource, but also local housing. We don't want to make a noise nuisance. We need to be considering how it ties in with things like airports. There's radar visibility, microwave links, comms, and just the cumulative visual impact that some of these schemes have. So the first thing we do with every organization when we look at wind is do a screening study to understand. It's quite a quick process just to understand if there are any sort of showstoppers that are going to make it so that project cannot be installed in that location. Then you're into that kind of energy generation analysis, mapping out to see how much that wind profile matches the generation. It tends to generate a little bit more in winter than in summer. Will generate day and night, but it's variable. So get windy days, get not windy days. For a 1 megawatt turbine project, you're probably looking something around 2 million quid, excluding grid costs. It assumes that we can do with limited or no grid upgrade fees in there. So again, needs to be considered. There are operational costs with a wind turbine. It's a rotating machine. It needs to be serviced or maintained. Somebody needs to keep an eye on it. Probably looking sort of 30, 40,000 pounds a year for doing that. And then you've got rate and rents that need to consider. So these will be looking at sort of 40 to 50,000 pounds a year. On the plus side, a 1 megawatt turbine can be generating something in the region of 400,000 plus kilowatt hours a year. At the minute, that's £500,000 worth of electricity if you're using that on site. So payback periods of a few years, again 4 years, is not impossible for behind the meter projects. So in the right location, definitely something to be considered, but it does come with higher constraints, more risks, and the timescales are longer. You could arrange for, if you can find the installers, you can have PV systems installed in a matter of months. Wind is going to take longer than that. And the main issue with that is to do with planning. There's a secondary issue to do with suppliers. Suppliers of small wind turbines, actually, as the turbines have got bigger and bigger, there are just less and less people that make those those smaller wind turbines. So we're down to 1 or 2 manufacturers. So actually, there's a bit of a supply chain concern around being able to procure them. We also have renewable heat. So traditionally, there's sort of 3 things that we've looked at: biomass, heat pumps, or anaerobic digestion. 10 years ago, we had a big push on biomass. It fitted very well with the RHI. It was an easy transition between existing fossil fuels and biomass systems, containerized. The operation of those schemes is more complex. It's a solid fuel. It supplied, de-ashed. So there's fuel handling, there's boiler operation. So when we talked before about, although there is no RHI available on new systems that go in, there are a number of systems that were installed back in RHI days, which still have an RHI tariff associated with them. And there are organizations that buy and sell those projects, and you can have the existing RHI 10 or 15 years that's left on that project can still be bought across and used on site. It does need consideration about how you're going to operate it and maintain it, and there are increasing things to do with air quality. But that's where a number of the biomass projects are working. Wood chip is not subject to the same fuel interdependencies to do with electricity and gas prices. So that the price of that fuel has actually remained relatively stable. Wood pellets, the price is tracking energy demands quite nicely. So the pellet price has gone up by 50% this year. So again, consideration around some of those points. Heat pumps are what we see of as going into most renewable heating projects at the moment in time because they're electricity fed. So they meet the decarbonisation targets for a lot of organisations, but they have technical complexity in terms of how you integrate them with buildings. To work most effectively, heat pumps need to run at lower temperatures, which means that the emitter systems, the radiators, the fan coils, even the handling units that they're connected to need to all be reviewed to ensure that they can operate at the right temperatures. So, and that means that drives down the input energy cost of how those systems run. So they can be really, really good and effective. They can also be used for cooling. Heat pump in many ways is a refrigeration system as well. So there are good savings to be made, but usually what we're seeing is staged progression where businesses are looking at their heat demands and how they progress things over time, both in terms of heat and also, in fact, process, the electrification of process plants. AD, you will only really see on sites where they have a reasonable amount of on-site production of organic material. They were very popular on farms a few years ago, again, with they were subject to both the feed-in tariff and the RHI, so they hit a little sweet spot. It's very site specific. So most of the AD plants that are going in at the moment are actually much larger schemes that are looking at generating gas that's being fed directly into the grid. So you might see them, but they're not things that we're seeing a huge amount of being constructed at the minute. By far, the largest thing we're seeing in terms of renewable heat is heat pumps. There are opportunities where we're not just looking at systems that people are building out themselves, but how they can tie in with either other financing opportunities or sort of other generators that can supply that energy to them. So with any of the wind and solar opportunities we looked at, as I said at the beginning, there are a whole series of organizations that will supply that energy to you in the form of paying for the capital cost for that system and providing you a fixed rate energy tariff over a period of time to reduce your energy costs without you having to invest in the system. So these kind of behind the meter PPA developers. And there are some very, very good business models available with this. And I know a number of organizations where they would prefer a sort of fixed monthly fee that they're paying to run that system. They appreciate they're probably paying a bit less, a bit more than they would if they'd invested in the system themselves, but they de-risk it. And depending on your business model, it's actually a very, very, very reasonable way of approaching it. That said, you have to be a little bit you have to make sure that you've done a bit of due diligence in the organization that's offering you that system. And you want to be aware of fixed fees, take or pay arrangements, the length of contracts to make sure that you understand what you are buying into. So a bit of research and due diligence on the developer that's offering you that PPA contract I would strongly advise, but it is something that fits with a number of organizations we work with. If you've looked at your energy demands, you're looking at a wider electrification, a wider sort of decarbonization strategy where over a period of time you're going to be removing existing fossil fuel plant, replacing that with electrified systems, then you're likely, depending on the scale of energy demands you have, to be in a situation where you cannot meet that through on-site demands alone. And that's where we start moving into sort of off-site PPA arrangements, where we're looking at the opportunities to lease nearby land and install either solar or wind opportunities at a larger scale and connect those by a private wire into a site. And then we have sort of bigger investment decisions, we've got bigger opportunities. It sort of decouples it from the geographic and physical location of your site. So we've got more things we can do. But again, that means bigger schemes, more time scale, a little more complexity. We have to think about the lease options, how much we're going to have to pay the landowner for building that system on their land. There are established sort of metrics that we can use to understand what a reasonable rate of remuneration would be for those landowners and for the land that the cable has to cross, because we have way leaves that go ahead with that. But depending on what you're looking at, we can be into acres, lots of acres of land, depending on your energy demands. With wind, if you happen to be next to a site that has existing wind turbines, one of the best things we can do is put up more wind turbines next to an existing wind farm, because from a planning point of view, that's actually easier to get away with, because that visual impact is already there. So we've seen some very good projects where people have been able to put an extra turbine or two next to an existing wind farm, and although they might have to run that cable across a number of fields, a couple of kilometers even, in some occasions, it's actually been the only way that we can viably get wind to power their site. So although it might seem that distance might be a limitation, it's not. If that's the thing that enables the permitting to go ahead, then it's actually quite a reasonable way forward. On the heat schemes, as we said, there are ESCO developers that will come along, and in the same way as the PPA arrangements, they will provide you with a heating system and then charge you for the heat that you take from it. That model has been extended to what's called heat as a service, where you will just pay a flat rate, and the person sort of operating the equipment will take some of the risk around fuel energy costs. There are different models associated with this. There are very few that have sort of come through to full commercial. Well, I'm not still waiting to see ones that sort of have this fully fleshed out, but there are a number of organizations that are looking at doing portfolios of heat as a service approaches. And then we have our pre-accredited RHI plant, things we talked about before, where you buy plant that's been installed, pre-accredited, can be moved to your location and reinstalled. So all of these are ways that you can look at either deferring the capital cost or benefiting from some of those original CapEx, those incentive schemes that were out there. In terms of the future opportunities, the two things that we get asked about on every single project that we do at this moment is, can I have hydrogen and can I have a battery? To be clear, hydrogen and batteries by themselves are not renewable energy systems. They are energy transfer or energy storage mechanisms. So you need to be generating electricity to be able to utilize hydrogen or a battery system. So we need that excess generation, and by far the best thing to be doing with your generation is using it to offset your existing demand. But where you have, talked about before, we have big dairy, for example, and that generation is going to happen at different times to your consumption, a battery can be a very reasonable way of moving that generation to the point of consumption. At the moment, batteries are quite expensive. So on a lot of the business models we've looked at, for most of the projects we looked at, if we just look at what the benefit of that load shifting, what's called diurnal load shifting it from the middle of the day to the evening to consume does, the payback on those batteries can be quite long. So what we tend to see is the viable batteries are ones where they can offer additional services. The grid itself needs extra services. It needs loads to turn on and off, to offer demand and frequency response services. So you can get an extra revenue stream for your battery by it being available to provide those types of operations as well as shifting loads. That can only work though if your battery is over a particular size. It needs to be at least 1 megawatt, and you need an aggregator, somebody that can play on those markets for you to optimize those values. They basically sell the service of your battery to the grid. So those aggregator revenues are variable. Depends on how good they are at being able to price your battery in terms of being able to offer services to the market. So although it can be incredible in terms of what they can do, trying to have a fixed understanding of what the long-term revenues are going to be is quite hard. Some people are very happy with that. Some people are happy to invest, but you do need to be aware that those revenue streams are more flexible and more at risk. In terms of hydrogen, hydrogen is an energy transfer system. We use the electricity at the most simple to split water into hydrogen and oxygen. You can store the hydrogen and then use it either to burn it in place of gas in terms of boilers, through fuel cells to turn back into electricity, potentially even as a transport fuel. It is something that is talked. If every project that was being talked about at the moment that you will have heard about was ahead, we would be living in a very different world. There's a huge amount of discussion around hydrogen, but actually the reality is that it's still a little further away than I think you might be led to believe. There are projects that are going ahead. There's a huge amount of sort of development to try and push those projects forward, but we are still ironing out some of the kinks. So when we talked before, I talked at the beginning about in terms of kind of projects that receive incentive investment funding, a lot of the hydrogen projects we're working, almost all of the hydrogen projects we're working on are ones where they've been able to access government funding so that they can prove the demonstration of those hydrogen schemes. They can be really good things to look at if you've got heavy good vehicles fleets, if you've got huge amounts of where we have the right sort of operation for it. And at the minute, we're in the odd situation where although hydrogen is quite expensive to produce, there is just not enough supply for the demands that we have. There is an burgeoning off-grid power market providing sort of zero carbon energy, which has a series of hydrogen generators which require a regular supply of green hydrogen, which they just can't source. So there are definitely opportunities there, but it's quite a hard square to circle at this moment in time. Terrible analogy. And the other thing is electric vehicle charging. The reason I've included this, although it's more a sort of future demand consideration. We're talking about the electrification of heating. We're talking about the electrification of process loads. You need to consider what you're doing in terms of the electrification of transport, because when you're thinking about grid connections, you're thinking about the energy footprint that your organization's going to have. If you're thinking about putting lots of electric vehicle chargers in the car park, then that in itself is more demand. How's that going to be met? If you're thinking about doing that, are you going to be incurring grid upgrade costs anyway? Something that you might be looking at if you're having to upgrade your on-site generation. So it's worth thinking about how that fits into your sort of energy strategy or decarbonization strategies. Right. That's the end of all the bits I had to run through. Thank you very much for your patience. We've got actually very slightly ahead of time, which is unusual. So I think if anybody had any questions, if you want to write them in the questions box down to the bottom right, James and I will see what we can do to answer them. That's flashing red at me, so I don't know what that means. Okay. Now there are no questions, which either means we did a really good job or everybody's struggling to find the question box.
I did answer a few questions throughout.
Okay. Oh, awesome. Perfect.
Made myself useful, you know. David, I've got a question for you.
Oh, go for life.
A big problem that I'm noticing is that a lot of people would like to change to more renewable heating sources, be it ground source or air source heat pumps, or maybe towards some kind of biomass boiler if it's ideal. Now, the questions about the environmental benefits of these systems are quite straightforward. However, economically, it is expensive, and actually the running costs are lower. They are lower, so there is a return on investment. However, they are quite prolonged returns on investments relative to other forms of on-site generation. Therefore, a really great way to enhance the economic argument would be to see the return of the renewable heating incentive. Do you think there is a chance that we could see more of these RHI type schemes coming back into the market?
Oh, that's an easy one. No. Unfortunately not. There is no discussion at the minute about anything that looks like a sort of RHI Mark II. The only current sort of discussion around sort of renewable heating incentives is around district heating networks and trying to so if you are either somebody that can produce heat or consume heat in sufficient quantities to be eligible for that, then there's funding that can help support interconnecting heat loads as a heat network. But at the moment, I'm afraid, although it was mooted originally when the RHI originally finished, any sort of impetus for that, unfortunately, has sort of dissolved. Or at least I'm unaware of anything at the moment that looks like it could be another renewable heat. There have been discussions around whether there could be a price for hydrogen in some sort of way, because hydrogen is as a fuel more expensive, because broadly it takes reasonable amounts of electricity to make hydrogen. So that is something where I would see there being more opportunity. But yes, I'm afraid I don't see there being. Having said that, you know, my chances are I'm now going to be somebody's going to come out and do it tomorrow. But
that'd be great. That'd be marvelous, though, really, because you know the electrification of heat is quite integral to a net zero future. However, the electrification of heat isn't the cheapest thing to set up. So it'd be ideal if there could be some way of either offsetting the capex cost or enhancing the return on investment mechanisms.
I entirely agree. I think the RHI was a mixed bag in terms of what it was able to achieve. But, right, I can see a few other questions that have popped up. So I'll between us, we'll see what we can do. Oh, right, every time you pop up a new question, I have to go and find it again. So where have we got? Business rates for installing solar. Yeah, it varies a little depending on where you are as to how they're calculated. It is unfortunately slightly opaque in terms of how they do calculate them. But it is something that does need to be considered. There is I'll see if I can get Divya to publish. There was some guidance around how about where you had to go to try and understand what the rates were in different areas. But for example, I'm based in Scotland, James, England. It's kind of even in those different areas, you see different ways that they are calculated. But broadly, it's because it's an investment. It's something that's added value. It does incur business rates.
I believe that in March, Rishi Sunak, in one of his budgets, actually made solar PV a non-rateable commodity.
Right.
So I don't think it's a rateable product anymore. So therefore, it doesn't incur business rates because there was quite a complex method to calculate it.
There are some, there are definitely some. I'm not sure it's on every bit of PV. There are definitely categories where if you do a certain amount of on-site usage, then they derated it within certain sizes. But again, that's part of the issue. Is it's not. My understanding is it's not all PV or everywhere doesn't have any business rates. It's certain PV for within certain categories. So I think
like
it's tied to do with this.
Yeah.
So yes, but this is why I say is that it's worth ensuring that you understand the situation, and it is not simple or clear. So yeah. Right. So I'll quickly go through some of these. What else have we got here? Any perspective on flow batteries for long-term storage? We've just done a feasibility project looking at flow batteries. They have for batteries typically are sort of lithium-ion systems, very similar to what you see in phones or electric vehicles. There are alternative battery chemistries. One is sort of using a sort of vanadium flow style system, which store as an electrolyte as a fluid. It has the advantage that it can store energy for much longer periods of time, and that's good for systems where you want to store that energy potentially over sort of one day, large amounts of area, longer periods of a day, or into other days. We're still only storing energy into sort of daily kind of range. We're not talking about storing energy into seasonally, just because of the amount of electrolyte of storage you would need. It's a very interesting technology. It's something quite interested in, but at the minute, although there are a few suppliers, there have been very, very few sort of projects that have gone forward, and the market at the minute is predominantly looking at lithium ion as their technologies. So
there's a question here which really caught my eye, which is to do with the demand in solar PV and how that may influence supply chains. And as a result, are we going to see issues with future supply? And to answer your question, we already had a major supply issue to start with, because one thing that's really imperative to a solar PV array is the inverter system. And the inverter system is heavily dependent on semiconductors. And the semiconductor supply was absolutely down the toilet during COVID. And the semiconductor manufacturing process is actually quite prolonged. So as soon as the kind of COVID manufacturing backlog was lifted, there's actually still an even longer backlog in order to manufacture these semiconductors themselves. So before we even had a supply issue as a demand side response, we had a supply side issue from a supply side mechanism. So to answer your question, we're kind of at the point where we're starting to catch up and starting to have more readily available inverter technology. But now we need to make sure that the market chain is able to produce the volume necessary to facilitate the dramatic increase in demand. So the answer is, yeah, there's a problem, but we already had a problem.
And to compound that, then we resolve the inverters and then the mounting systems. You know,
the steel. God, yeah, goodness.
Mounting systems, PV supply. Almost all PV modules are made in China, and when different countries, because they're again a tradable international commodity, when different countries launch their different incentive schemes and their different programs, you find that a lot of supply gets shifted to other countries. So because we're actually not in the grand scheme of things a huge market, it's been the same for heat pumps as well. We're actually struggling to get a number of these systems because we're quite small in terms of the volume of sort of product that we're consuming. So we're not deemed to be so much of a priority market. Laura had asked about dealing with housing associations, governments where they have local governments where they have multiple sites. They want to produce their own generation, but give back a portion to local communities. So we've worked on a number of projects where sort of housing associations or community groups have built out, have funded and built out predominantly PV systems, where they have agreed a PPA system, like we were talking about with BIT, where those organizations become the PPA developer and provide a reduced energy cost to consumers. And then they've taken a percentage of they have a business model where they are paying back their shareholders, their sort of community investors, to pay back for the capital for the systems, and then they're putting a ring-fence community fund so that money, when systems make profit, can be reinvested into the local community. If that's what you're asking, then yes, there's definitely models where that works. In terms of being able to sort of proportion out the energy itself that's generated, unfortunately, once that energy leaves a building and goes into the grid, you've sold it to the grid, and you can't then direct it somewhere else. There are virtual PPA arrangements, but they are much more complicated, and there's something that you need. You need the people you're buying and selling electricity to engage at both ends. So it's not something at the moment that you can do sort of directly selling that electricity to it. You can only directly sell electricity to the building that you are wired into. Johnny had asked about anaerobic digestion for a small-scale distillery. The simple answer is it would depend, and I'd have to talk more about what your materials are, I'm afraid. There's what else? Sorry, we're about to run out of time. Second-hand EV batteries to bring down capital costs. Really interesting. There are a couple of manufacturers, organizations that are doing exactly that, looking at using second-hand vehicle batteries. So it's not, I've not done any projects where they've used that system, but I know that organizations are out there. They're doing it by their very nature. Those batteries have already had a life, so they've got a lower life expectancy. They've already sort of been worn a bit. But if that reduces the capital cost, then it would be worth considering. But I'm afraid I don't have any direct experience of trying to implement those types of projects. But something that could definitely be considered. What's we got here? Laura had also asked about combining PV batteries and ground source. Absolutely. I mean, they're all electrification systems. So you've got generation, storage, and consumption. The battery is the bit that's the most sort of tenuous part in there, because what you really want to be able to do is to get the heat pump to run when the generation is generating, and that could be both in the forms of the heat pump itself running, or what we tend to see more of is the hot water usage being linked to the generation of PV. So it feeds the on-site demands, and then the next thing it does is charge the hot water system, and then it exports the electricity. Heat pumps, if you've got a solid slab, can run at sort of background level and charge the building, so that can be a way of doing it. But you do have to bear in mind that unfortunately PV generates mainly in the summer, and you want to heat mainly in the winter. So there is a sort of seasonal disparity between those things, and unfortunately the battery can only really take energy from the day and able to use it at night. It can't take it from summer to winter. So it doesn't entirely help with that, I'm afraid. Well, haven't we really covered?
Yeah, the response I had to that as well is that, yeah, they absolutely work together, but also they need to be modeled properly, because at the end of the day, you don't want to oversize your solar PV, nor do you want to undersize it. And you want to just make sure that all things are working harmoniously, because these are actually non-continuous the solar PV is a non-continuous generator, whereas the heat pump may be a continuously generating activity. So you don't want to, like, a cowboy move would to be to say, oh, this heat pump's going to use 300,000 kilowatts a year, therefore we'll get a solar PV array that will produce 300,000 kilowatts a year. It doesn't work like that. So it's important that you have someone that's able to properly calculate how much the heat pump would benefit from the PV array, and then how much the battery may be able to charge and discharge and offset those consumptions. So that's my answer to that as well. Is yes, it's perfectly feasible, but it does need a little bit more nuance than just hoping for the best kind of thing.
Right. Charlotte, you'd asked about renewable energy relief post 2016. I have to admit, I'm afraid I don't know specifically what that refers to.
I think they were wondering if the FIT tariff was still being honoured.
Oh, right. No, relief. Maybe. If that's the question, the FIT tariff is definitely still being honoured. In fact, they've recently come out with a scheme where we can, where people that had generators that are not operational, or not very functional, there were limits on what you could do in terms of replacing feed-in tariff generators, and it's still be eligible. Ofgem have recently changed the rules, so we have a number of projects we're looking at. It's relatively recent, in the grand scheme of things, changes where we can look at repowering or replacing existing, traditionally wind, but could work for PV sites that are not performing effectively, and using that and still getting all or a proportion of the feed-in tariff that a site was getting. So that's it. I'm not quite sure that's what she is asking, but you may have to send us a message directly, and we'll try and see if there's a more, if we misunderstood. And again, apologies if James and I have misunderstood what you've written anyway. Then get in touch, and we'll see if we can come up with a better answer. Okay, I think we're just about coming up to time. So that just leaves us to say thank you very much for your attendance and your attention.
Yeah.
And, if you do have any other questions.
Thank you. I'm happy with the turnout as well, and I hope you didn't mind looking at my ugly mug. But fortunately, David was here to add a bit of glamour to the event as well.
It's the first time I've ever called glamorous today. So right, really good speaking to you all. Thank you very much for your time. Cheers.
Thank you. Bye.